Hi, Assalamualaikum. My name is Noor Nishazwani Betty Muhammad Rafi. My ID number is MB19047. This is our project title, which is Piston and Connecting Rod. I will present about the introduction. A piston is used in reciprocating engines, reciprocating pumps, gas compressor, hydraulic cylinder, and pneumatic cylinders, among other operations. A connecting rod, on the other hand, is a component of a piston engine that links the piston to the crankshaft. The connecting rod, in conjunction with the crank, turns the piston reciprocating action into crankshaft rotation. A connecting rod, often known as a rod or con rod, connects the piston to the crankshaft. Our objective for the project is to develop the basic model of the system and simulate it in Autodesk in maintenance run, and to determine the maximum load, higher displacement, stress and strain in the system. Next is to design an improvement that can be done to improve performance of the system in terms of deformation, stress and strain. The last one is to construct the basic model with the enhanced design. This is the complete 3D drawing for the first design, which is A is piston. Next is the piston pin. Next, connecting rod. Next, piston cap. Next, screw. Full part. And the last one is the exploded view. That's all from me. Thank you.
Hi and Assalamualaikum. My name is Khairun Nisa binti Azni. My ID number is MA19102. Now, I'm going to present about design improvement. First, our improvement is a piston. We change the material from steel to aluminum alloy because of its low density, high thermal conductivity, and high reliability is more convenient than steel. Next, we change the material for connecting rods, which is to the titanium because it is lighter than steel and it can absorb high impact. Okay, this is a full part for after we already improved the material. Okay, from the slide you can see it's the material that we use to design this piston and connecting rod.
Hello, my name is Nurul Syafiqah binti Fauzi. Okay, in this report, I was the person in charge in pre-processing setup illustration that contain of the applied load, constraint, material, and also the boundary condition. So for the applied load, this is the image of our model, which is constraint of piston, connecting rod, piston cap. So there are three major forces applied to the piston and connecting rod. Two forces at the connecting rod, and another one is at the piston. So in this table, we are already decided to use the load which is equal to 100 to the piston and also to the connecting rod. The force acting on the connecting rod are forces due to the maximum combustion pressure acting on piston top surface during combustion stroke, and another one is the force due to the inertia of connecting rod and the reciprocating masses. Meanwhile, the forces acting on the piston is due to the gas pressure and inertia of the reciprocating part. So that's for the applied load. We continue with the constraint. In the constraint part, constraint is a limitation or restriction at certain area from being affected by the external forces applied. And constraints are important to know which place are fixed in the direction at Y and Z without any moment or forces. In this case, the area at the piston cap and connecting rod are fixed in X, Y, and Z direction. So we proceed with the material. For this piston and connecting rod model, we choose aluminium C101 as the main material for the piston because it is an optimal material. And also the piston is subjected to the high heat, inertia, vibration, and also friction. So that's why aluminium C101 is the best option of material that we want to choose. Meanwhile, for the titanium, for the connecting rod, we use the titanium because it is lighter than the steel and can withstand heavy impact. So that's for the material. We proceed with the boundary condition. For the boundary condition, 3D cube aligned to the global X, Y, and Z axis that exactly contain a body or assembly. Okay, that's all from me. Thank you.
My name is Nur Syafiqah binti Adira. I will continue this presentation for mesh convergence. It can see that this is the mesh table for before and after improvement of piston and piston rod. Next, for the mesh graph, it can see that the differences between before and after. The strain energy is a parameter which will be used to calculate the error in global mesh refinement. It shows the graph of mesh convergence of the piston before improvement, which is the rate convergence is negative 3.72432% with error 0.101223, and after improvement it will be 11.4109% with error 0.0631309. After that, the graph of mesh conversion of the piston rod before improvement, which is 0.482263% with error 0.0499644, and for the after improvement is 0.300348% with error 0.03863898. It shows that the conversion rate is increased after the improvement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Haji bin Mazhar, ID number MA1914. Today I will explain to all of you about our group discussion. Okay, in this slide, I will show about the displacement, strain and stress about before the improvement and after the improvement of piston cap and connecting rod. Okay, this is the displacement and the connecting rod. Okay, this is for the strain. Stress before the improvement, and this is the piston cap. You can see the difference. And this is stress for the connecting rod before the improvement. Right, this is the displacement after the improvement. You can see the piston cap after the improvement is better than the before. Also, the connecting rod after the improvement. And strain. So the connecting rod after the improvement for the strains, and stress for the piston cap, and stress for the connecting rod after the improvement. As you can see, this is a summary result for before modification, and in this table I have put the maximum and the minimum, the displacement, strain and stress for each piston and connecting rod, which is a displacement of maximum displacement for the piston like 126.9, and for the connecting rod is 2.249 exponent 4, and also the strains and the stress. Okay, and this is the summary result after the modification. Same as the before the modification, I have put all the maximum and minimum displacement, strain and stress in this table, and you can see the result is better than the than before the modification, which is the displacement, strains and stress is lower than before the modification, such as the displacement is lower, which is the maximum displacement is 3.578 exponent negative 8. This is the lowest than the before the modification. Alright, for the last one is the comparison before and after modification. This new design or the design after modification has a lower maximum displacement as the sequence of our comparative testing. When compared to the initial design model, this distortion has been reduced. The maximum amount of one missed stress is reduced. As a result, the stress is now substantially further away from the yield limit than it was before the adjustment was performed. When compared to the original model deformation, the maximum strain has lowered as
Okay, for the conclusion for this our project was to construct an analysis utilizing event Nelson for a basic piston and connecting rod design, as well as an improvement design. We get an appreciation for event Nelson basic theory and application through a combination of lecture and laboratory practice. To finish a project involving the design of a piston and connecting rod that must meet material, load, and constraint requirement, we apply the finite element approach. We gain a better understanding of machine issues, the significance of boundary condition, and how to implement results. The project-based approach to the finite element method gives students an understanding of how effective the method can be in structural analysis. That's all from us. Thank you.